Hello, maurieos. CEDM Subdivision Project Briefing, Part 2, Layout and Earthworks. Hello, welcome. In this video, we're going to take a look at the Part 2 of the project, the Layout and Earthworks. So, well, let's find it first up. So here in the dashboard, we go to the civil engineering there, and under assessment, we'll see there's project part 2, layout and earthworks. It's worth 15%, and it's due on the 21st of August. So we move down here to part 2. This is the video that we're just recording at the moment, and here's the page with the layout of the project on it, and here's our details. Okay, so that was pretty straightforward, really. We could make this a little bigger perhaps, and see how we go. So Centre for Engineering, Layout and Earthworks, as we can see there, we've got the due date and time here, 21st of August, like so, 2017. The learning outcomes, which are the same for the whole project and in fact the course, so nothing to there. It's worth 15%, and the aim is to understand the parameters associated with the layout of a subdivision and using surfaces to calculate volumes. So the objective is to finalise the layout for the 20 to 30 lot subdivision with a minimum of one intersection, one horizontal curve, one vertical curve, one cul-de-sac head, and to calculate the volume of a stockpile and an excavation. So pretty straightforward, really. Finalise the layout of your subdivision, which is from part 1, by completing layout plans showing the lot layout, including areas, setbacks, platforms, building platforms, and typical street cross sections. The earthworks, your site has been used to stockpile, so you've got to make a suitable story or scenario to put this into some sort of context. It's largely fictional, remember, so you can be a bit creative. Your site has been used to stockpile approximately 1,500 metres of topsoil, so you need to first of all start by trying to visualise how big that stockpile might be with a few back of the envelope or Fermi mathematics calculations, so that you can sort of get an idea of how big to make your stockpile, and then put it in a location on your surface that you created in part 1. Remembering that the stockpile will sit on top of the surface you created, and you'll remove the stockpile, so you'll be left with the surface you created. So that's very good there, 1,500, and then approximately 1,200 metres of unsuitable material has been identified and needs to be excavated from your site. So you need to work out, the dimensions of what a 1,200 cubic metre approximately excavation might look like, and show that on your site. Of course, the material will be excavated and backfilled, so at the completion of the exercise, your new surface will look exactly like your original surface. You've taken some material out and you've put the equivalent back in. So show the location of the unsuitable material and calculate its volume. Now your client probably want to know about this for a number of reasons, so write a suitable report with plans and calculations for your client explaining the situation. So this is putting it into the context, the fictional context, so you can be a bit creative here. And the volumes of material involved. The outputs should be in PDF format, include CAD drawings with title blocks. Now remember that these plans and things are a milestone event in the course of the overall project. Are there as a guideline, as is the marking schedule. So you can put in the work that you've done and got that marked and look to get improvements and things like that on it. The assessment, The CAD plans and report in PDF format will need to be presented for evaluation. And then we will go to here, and here's our marking schedule. So the plans should be on appropriate and completed plan forms, consistent. The lot layout is clear and logical. Evidence that the lots meet Hamilton City Council requirements or some other territorial authority if you so desire. Setbacks and building platforms are shown on the plans. Lot areas are shown. The plans have a north point. Typical cross sections are shown on the plans. Total area shown on layout plans, and all land is accounted for. Very important. All land is accounted for. Remember that the road, until it is dedicated and becomes council property, is in fact a lot on the plan, and it will have an area. So you start with a total area, and the sum of all the lots and all the road should add up to that total. You know, land doesn't suddenly appear. So that needs to be quite clearly done and accounted for. The land is a very important resource in the subdivision process, so you must account for it. A stockpile with volume is clearly shown on the plan. An excavation with volume is clearly shown on the plan. The Earthworks report follows a recognised format, and the Earthworks report includes a suitable record of volume calculations. The key data and information is clear and easily interpreted, and the plans have been checked and there are no obvious errors, for a total of 15 marks. Each of these will be marked out of, these are effectively a weighting, each will be marked out of 10 to give you an overall mark on the overall spreadsheet that I've introduced to you earlier. So let's maybe just have a look at an example. What happened there? We need to go back to, here's an example here that I have got from the website actually. So perhaps we should actually go into Moodle and show you where these can be found. So let's get Moodle operating here. What's happened? Is that it there? That can drop down from there. Oh, here we go. Okay, so we need to go into the dashboard, and come on, it's taking a little bit of time. Sorry about this. And there we go. Now, if we look at the subdivision design here, right down at the very bottom, I have a progress to date, and this is a set of plans of the subdivision that I was showing you there before. So there we have the existing topography plan there, the cadastral data and survey control. Here's the layout and the land use plan, which would, so all of these three plans should be ostensibly completed at the end of part 2. And then here we have the preliminary earthworks. So I've called it the preliminary earthworks plan because further earthworks will be required when we do the thing. And so here's the unsuitable excavation shown there with a volume in an area, and the topsoil stockpile shown with a volume and an area. Keep it very simple, and yeah, you can't go wrong. Just remember everything's filled in here, so you need to have names and get people to check in that. And so far you'll notice here I've just got 4. I haven't finished the of because I don't know how many are in the set. Just a little bit of a tip here, there's the logo here needs to be sent to the back. There's some lines through here that should show up and they need to be brought to the front. This is a common problem with this template, so you need to rectify that at the final stage just to make sure that it shows up correctly. As it is here, you can see there's a black line around the logo. So that would probably up to there, that sheet 4 would give you the end of stage or part 2. Here's your typical cross section. Keep them fairly simple for the purposes of this exercise. You don't want it too complex. And also here's a bit of curb and channel. Again, keep it fairly simple with straight edges rather than curved edges, which will add added complexity into the modelling situation. So there you go. That's pretty much what will be required at the end of part 2. As you can see there, with some examples and what have you. So I think that completes this briefing. If you have any questions, you can send me an email, or talk to me in person. With an email, I can record my answer and make that available on the course Moodle site. Alrighty, cheers. See you.